Let's talk about a high-stakes search for the building blocks of life on Mars. And it all hinges on this one-time-only experiment happening right now, conducted by a lone robot millions and millions of miles from home. Okay, so let's just picture this. Way out there on the surface of Mars, inside a place called Gale Crater, the Curiosity rover is at this absolutely critical moment in its mission. I mean, after more than a decade of exploring, it's performing a final, totally irreplaceable test that could literally change everything we think we know about the red planet. You see, at the heart of this whole story is our car-sized hero, Curiosity, and it's doing something incredibly rare. It is about to use the very last of a special solvent that it carried all the way from Earth. Think of it like a chemical key, one designed to unlock secrets that have been hidden in Martian rock for billions of years. And to really get the stakes here, you have to understand just how scarce this stuff is. Curiosity landed on Mars with only 2 tiny cups of this solvent. It's called TMAH. Just 2. That's it. This is not some routine, everyday test. This is the final shot, using a precious, finite resource that they saved for the most promising target they could possibly find. And to put that into perspective, the first cup, that was used way back in 2020. It has taken 6 years of driving, of analyzing data, of careful planning just to find the perfect spot for this final test. I mean, an opportunity like this is basically unheard of on another planet. So why is this one test so important? What's the big deal? Well, to get that, you gotta understand the huge challenge of looking for life on Mars in the first place. You see, the planet itself is this incredibly hostile environment that is actively destroying the very evidence we're looking for, those complex carbon-based molecules we call organics. It's like trying to investigate a cosmic crime scene where the evidence is constantly being erased. Let's meet the culprits, shall we? First up, you've got cosmic rays. These are high-energy particles from deep space that just slam into the surface, getting deep into the rock and shattering fragile organic molecules. Then you've got the intense ultraviolet radiation from the sun. It triggers chemical reactions that basically act like cosmic bleach on the soil. And if that wasn't enough, the soil itself is full of these reactive salts called perchlorates, which can literally cook any organics they find, turning them into plain old carbon dioxide. But here's the thing. Despite this constant cosmic assault, we are not starting from scratch. For years, our rovers have been following this trail of breadcrumbs, right? Finding these tantalizing little hints that suggest we're on the right track, and that maybe, just maybe, some of those organic molecules managed to survive. For example, Curiosity has found organics before in a mudstone called Cumberland, and its sister rover, Perseverance, has also spotted some really intriguing materials over in Gale Crater that are totally consistent with the remains of ancient life. But here is the real kicker. A recent study basically concluded that meteorites crashing into Mars can't explain all the organics we found. Now, that doesn't prove life for sure, but it absolutely keeps that incredible possibility wide open. And the stakes just could not be higher. I mean, listen to what NASA's Nikki Fox said when reflecting on some of these very findings. Quote, "This is the closest we've actually come to discovering ancient life on Mars. Every single clue gets us one step closer to answering one of the biggest questions humanity has ever asked." Okay, so that brings us back to this final experiment. What makes it so different? Well, after that first test in 2020, the scientists didn't just hit repeat. Oh no, they refined everything. They developed a brand new technique, perfectly tailored for this specific, incredibly promising new location. At the core of all this is that special solvent, the TMAH. Just think of it like a chemical master key. See, when you just heat a rock sample to see what's inside, a lot of the complex organic molecules just get destroyed in the process. But TMAH, it gently unbinds these molecules from the rock and keeps them stable. This allows the rover's onboard lab, which is called SAM, to get a much clearer picture of what's really in there. But the location is just as important as the chemical. The rover is now in this fascinating place called a boxwork terrain. It's this network of ridges that scientists think formed from the very last trickles of ancient groundwater. And, crucially, this rock is packed with clay minerals, and their layered structure can act like a natural shield, protecting any delicate organic molecules from all that harsh Martian radiation. It's the perfect hiding spot. And the process itself?
It's been totally upgraded. First, the team back on Earth ran a full dress rehearsal to make sure the incredibly complex sample handoff went off without a hitch. Then the powdered rock got mixed with that final precious cup of TMAH. And finally, instead of just one high heat blast, the sample is being heated in stages. It's a new workflow designed to better mimic the sophisticated labs we have here on Earth and hopefully give us the clearest results yet.
So, what happens after this final test? Once the data comes back? Well, this experiment, as critical as it is not the end of the story. It's actually a vital clue for a much, much grander, multi-decade mission, bringing a piece of Mars back home to Earth. Yeah, we're talking about the Mars Sample Return Campaign, a massive joint effort by NASA and the European Space Agency. And honestly, it sounds like something out of a sci-fi movie. It's basically a three-part interplanetary relay race. The first leg is already happening. Perseverance is collecting and stashing samples right now. The next steps involve sending a lander to pick them up, launch them off of Mars, and then have an orbiter catch the container in space for the long journey home. Wild. And this isn't some far-off dream. This is happening as we speak. Perseverance has already filled up a bunch of these sample tubes with rock, soil, even some Martian air. It's even created a little backup stash, dropping a collection of tubes right on the surface, just in case. They're making sure these precious samples are ready for their future ride home. Because ultimately, look, our rovers are incredible. They're the best field geologists you could ever ask for, but they have their limits. To answer the biggest question of all, was there ever life on Mars? That's going to require instruments far too large, too complex, too powerful to ever send to another planet. The final verdict, that yes or no, it's almost certainly going to have to be delivered right here in our labs on Earth. So you see how it all connects? This one experiment, by curiosity, with its one last cup of solvent, is helping scientists decide which of those samples are the most vital ones to bring back. It's a single, critical step on a very long journey. But just imagine for a second if that journey is successful. If those tubes return to Earth and, inside, they reveal the undeniable signature of ancient life. How would that discovery change our view of the universe and our place in it?